Okay, today we're going to talk about using trig ratios to find missing side lengths. Last class we just set up trig ratios with the opposite, adjacent, and hypotenuse side. Now we're going to actually find missing side lengths. So in order to do this, you're going to need a scientific calculator with the sine, cosine, tangent operation. Okay, so I've got a calculator here that has a sine, cosine, tangent. So you need a calculator with one of these. If not, there's plenty of programs and apps out there that have these, and they're all for free. So you can download one or just Google it and find a calculator with that. So we have to remember that we always are taking the sine, cosine, tangent of some angle. Okay, so this is an example. The sine of 30 degrees, we're going to take that in our calculator. So I'm going to take the sine of 30 degrees, and it should equal 0.5. Okay? So this should equal 0.5. Now if you see like all of a sudden like the sine of your if you take the sine of 30 and it equals something else, like negative 9.88, you are in the wrong mode for what we want. In geometry right now, because we're working with degrees of angles and triangles, we want to be in degree mode. So if you saw I changed the mode of my calculator, you need to change the mode, and if it's in this one, the radians mode is going to be used in like calculus. Okay, we're going to move to degree mode because we are just in geometry. So we're going to select the degree mode. You can clear it out, and then you should get the sine of 30 is equal to 2.5. Okay? So notice that earlier I closed the parentheses. This time I didn't close the parentheses. You don't really need to do it right now unless there's an operation afterwards. Then you need to close the parentheses. So sine of 30 is 0.5. If we continue, what is the cosine of 56? Let's just make sure that you get the same answer as us. It should be 0.5591. Now I said round to the nearest thousandths, which is 3 decimal places. So we'll round the 1 keeps the 9 and 9, so 0.559. And the last one, let's just make sure everything's working. The tangent of 78, round to 3 decimal places. The 6 is going to round, or the 6 is going to round a 4 to a 5, so 4.705. Okay. Now the idea of this is that when we use our calculator, anytime we take a trig function of some angle, it is a decimal value. Sometimes we have to round it, sometimes it's like 0.5 where it terminates. Okay, so if we're talking this triangle down here and we're trying to find the sine of z, okay, here's the angle z. Let's first label the opposite, adjacent, and hypotenuse side. So across from the triangle is the opposite side. The adjacent is the other leg in the triangle, and we know the hypotenuse is always the longest side. Okay. So sine, and if you need to write SohCahToa, some old horse caught another horse taking oats away. Sine in the SohCahToa is O and H. So the O comes on top, the H is divided on the bottom, so it's opposite divided by hypotenuse. So in this case, the opposite is 8, the hypotenuse is 10. So this is a fraction that equals 8 divided by 10. Now, with this 8 divided by 10, you need to, or you don't need to, but right now we're going to put this in our calculator. If you did 8 divided by 10 in your calculator, 8 divided by 10, you would get 0.8, which is 8/10. So just remember, the angle of the sine of some angle is a decimal or a number. It won't always be just a decimal, but for sine it will always be decimal less than 1. Okay. So let's do the cosine of that same angle. Cosine is A and H, so the A goes on top, the adjacent divided by the hypotenuse. Well, that's 6 over 10. And 6 divided by 10 is going to be 0.6. And the last one, tangent, taking oats away. Tangent in the TOA is O and A, so it's the opposite divided by the adjacent. The opposite is 8, the adjacent is 6, so 8 divided by 6. Now 8 divided by 6 isn't a perfect terminating decimal. So if you took 8 and divided it by 6 in your calculator, you're going to get 1.333, and it would just repeat forever. So this is one where you would have to round it, or you could just say it's 1.3 repeating, but eventually we would have to round this answer in the future. So not all of them terminate like 0.8 and 0.6. Some of them go on forever, and you will have to round it like a couple of these examples up here. So that's just using the calculator and the sine. We're going to actually now go ahead and do an example that finds this missing side x down here. In order to find a missing side length in some right triangle, we are required to have at least an angle measure. So in the example down here is 59. We're given an angle measure, and we must have at least one side length. 20 in this example. So I have a 6-step process, or 5-step process to help you jump through these steps in finding this value of x. So first step is to identify the opposite, the adjacent, the hypotenuse sides according to the given angle that we have. The given angle is 59. So I'm going to label all of these side lengths according to their side length. So opposite is across from that angle. The adjacent is this 20, the other leg that makes the right angle. And the hypotenuse is this longest side, but we don't have that labeled as a side length, but we don't really need it as long as we just have one side length. Okay? So step 2 is identify what do we know. Well, we know this side length of 20, and the side length of 20 is the adjacent side. Okay? But what we are trying to find is this x, and x is the opposite side. So step 2 is identify what you know. Step 3 is identify what we want to find. So we know the adjacent and we want to find the opposite. So we have the A and the O in our trig ratio. That corresponds with step 4. To identify the trig ratio, we need to use one of them that has an O and an A. Well, that's the TOA in SohCahToa. So step 5 is now set up the trig ratio. Well, we know that the tangent of this angle is going to equal the O first, the opposite divided by the hypotenuse. So down here, I'm going to set up the trig ratio using the degree 50 and the side length 20. Okay. So tangent of that angle 59 degrees is the opposite side divided by the hypotenuse. Well, the opposite side is x, so x goes on top of my fraction in the numerator, and the adjacent is 20, that goes in the denominator. So now you have this trig ratio set up. The tangent of that angle is equal to the opposite divided by the adjacent, x over 20. We are going to solve for x next. In order to solve for x, this is taking x divided by 20. We have to eliminate the dividing by 20, so we're going to multiply by 20. That eliminates the dividing by 20 as a fraction. But to multiply by 20 on the right side, we have to also do it on the left side. So now our result is taking 20 and multiplying it by the tangent of 59. Then all that's left on the right side is equal to x. And this is where the calculator is going to help. Assuming that you're in the correct mode, degree mode, we're just going to take 20 and multiply that by the tangent of 59. And 20 times the tangent of 59 is 33. And let's round it to just 3 decimal places like last time. 2855, so the 5 is going to round the third 5 to a 6. So 33.286. So the x value of your side is approximately 33.286. And that's the solving for x. So this side length here is 33.286 units, whatever the units are. So I'm going to flip the paper and we'll do another example, solving with the same 5-step process. So this example, we'll solve it, but now we're going to round it to the nearest hundredth. Okay? So the step-by-step process, 1, identify the opposite adjacent hypotenuse according to the angle. Now the angle we have is 55. Opposite of 55 is this x. The adjacent side is unmarked, but the hypotenuse this time is marked. So step 2 and 3 is identify what we know. In this example, we know 12. That's the hypotenuse. So 12 is the hypotenuse. What we want to find is x, and x is the opposite. So we know we have an h, and we know we have an o for hypotenuse and opposite. In step 4, identifying the trig ratio, we need to find one of them, sine, cosine, and tangent, that uses o and h. And you'll see that sine uses the o and the h. So the sine is a ratio of the opposite divided by the hypotenuse, because opposite comes first, hypotenuse comes second. So I'm going to set up a trig ratio, an equation that uses this angle specifically. The sine of that 55-degree angle is equal to the opposite, x, divided by the hypotenuse, 12. X divided by 12. So there is your trig ratio set up with the x and the 15, or the x, 12, and 55 all together. Now we're just going to solve for x. So to eliminate the denominator of 12, we're going to multiply by 12, both on the left and the right side. And so your result is 12 times the sine of 55. And again, I'm going to put that to my calculator. 12 times the sine of 55. And that is equal to 9.829. Now, if you remember, we're rounding it to the nearest hundredth. So that's only 2 decimal places. So the third 9 is going to round the second decimal to a 3. So 9.83. X is approximately 9.83. Whatever the units are, that's your missing value of X. So there's 2 examples when the fraction has X in the numerator. We're going to do an example if X is in the denominator of our solving. But I'm not going to give you the 5-step process. You can look up here or we can kind of jump through it. So step 1 is identify the opposite, adjacent, and hypotenuse side according to the angle that we are given. So the opposite side of 62 is this 11. The adjacent side is the X, and the hypotenuse, always the longest side, is the unmarked side. Okay, so we've checked off step 1. Step 2 is identify what do we know. Well, the side length that we know is 11. So 11 in this case is the opposite side. Step 3 was find out what side length do we want to find. Well, we want to find X, and X is the adjacent. So 4, we're going to identify in SohCahToa which trig ratio. We have the opposite, we have the adjacent, or we want to find the adjacent. In this, the tangent uses the O and the A. So step 5 is setting up the trig ratio to solve for this. And the tangent is equal to the opposite divided by the adjacent. So right here, I'm going to use that space to actually set up the equation and solve for X. So the tangent of the angle 62 is equal to the fraction of the opposite divided by the adjacent. Well, the opposite is 11, and the adjacent side is X. So this is the trig ratio set up. Now, just like the last one, if we had 12 in the denominator, we multiply by 12. This time, though, we have X in the denominator, so we're going to multiply by X. So what you have that remains is X times the tangent of 62, and that's equal to just 11. Now, if you remember me saying, like the tangent of 62 is some number, okay? So this is really X times whatever that number is. Now, I'm going to put that into my calculator. The tangent of 62 is this decimal, 1.8807. And in order to get a more accurate answer, I'm going to keep this to 4 decimal places because we want to round as little as possible early on. We'll round the final answer, but this isn't our final answer yet. This is just a tangent of 62. So we'll round our final answer to 2 decimal places, but we'll keep this one as 4. So this is 1.8807, and that's equal to 11. Now this is X times this number. So in order to solve for X, the opposite of multiplying by 1.8807 is dividing by 1.8807. That doesn't look like an 8, but that's an 8 there. So what we have to do is take our calculator and do 11 divided by that number, 1.8807. So 11 divided by 1.8807 equals 5.848. And like I said, now this is our final answer. This is what X is equal to. Let's round this to 5.85. So X is approximately rounded to 5.85 units. Okay. Now what we could have done is just take the 11 and divide it by the tangent of 62. And you'll notice we get the same answer. So I'm going to take the 11, and without actually doing 2 intermediate steps, we'll just do 1. And take 11 and divide it by the tangent of 62. And you see that we get the same answer, 5.85 rounded. Now the decimals really far down the line are different, but the most important thing is right now what we have at the beginning, so the 5.85. So there's one last, you try it. You can go and pause this video or you can just watch it, but I'd like you to pause it, try this, let's see what you get, and then unpause it, play, and see if you get the right answer. So pause it right now and you can play later. Okay. So step 1, identify the sides. So here's the opposite. The adjacent is 12, and the hypotenuse is X. Okay. So what we have is 12, and 12 is equal to, in this case, the adjacent side. What we want to find is X, and X is equal to the hypotenuse. So we know in SohCahToa, we need to use the A and the H. Well, which trig ratio uses the A and the H? That is the cosine, because cosine is A and H. So the cosine of this angle, 33 degrees, is equal to the A first, then the H second. The A is 12, the H is X. So it's 12 over X. That is your original trig ratio. Now we are going to solve for X. So in this case, let's solve for X. Multiply by X, because we're eliminating that denominator if X is in the denominator. So you get X times the cosine of 33 is equal to 12. But the cosine of 33, remember, we can put that into our calculator and take the cosine of 33 and equals, that's 0.838. I'm going to round this to 8387. That's 0.8387 equals 12. Then we're going to divide out by the 0.8387, 0.8387, 0.8387 to get the X. And so over here, X is approximately, let's see, 12 divided by that 0.8387 should be 14.3. Let's round it to 3.1. 14.31. So your answer should be 14.31. Again, I'm going to do this. You could have just taken 12 right here and divided it by the cosine of 33. So if I take 12 and divide it by the cosine of 33, I should also get 14.31, which is exactly what we got earlier. Okay, so that's your answer.